This is part 2 of the lesson on linear functions. Let's talk about the intersection of two lines. To find the intersection of where line f of x equals to mx plus b and g of x equals m2x plus b2, set the two functions equal to each other and solve f of x equals to g of x, which is equivalent to mx plus b being equivalent to m sub 2x plus b sub 2. So basically, if we have two different lines, to figure out the point of intersection, we set them equal to each other and the resulting point will be their intersection. For example, a rental company offers two plans for renting a car. For the first plan, we pay $30 per day and 12 cents per mile. So the cost is given by, there's a fixed fee of $30 per day. Notice there's no variable there because it's a fixed fee. And for each mile, the charge is 12 cents. Now this is a variable because this cost is going to change depending on how much we drive, whereas this cost is going to be fixed. Plan B, it's $50 per day with unlimited mileage. So the cost under the second plan is just $50 per day. It doesn't matter how many miles we drive. So question is, after how many miles will plan B be cheaper than plan A? Now let me explain this real quick. So let's compare our two plans. So for plan A, let's say we drive 10 miles. And under plan B, let's say we also drive 10 miles. Let's see what happens. Under plan A, the cost is going to be the fixed fee of $30 and 12 cents per mile. We drove 10 miles, so it'll be 0.12 times 10. So this is going to be 30 plus 120, and that's going to be 3120. Now under plan B, for the same number of miles, remember plan B is $50 per day, doesn't matter how much you drive, the cost is going to be $50. So if you drive only 10 miles under each plan, plan A is going to be cheaper. So the question is, after how many miles will plan B be cheaper than plan A? So let's find their intersection. We will set the two costs, which are 30 plus 0.12 m and 50 equal to each other. So we have 30 plus 0.12 m equals to 50. We move the 30 to the other side, so we get 0.12 m equals to 20, and then we are going to divide both sides by 0.12, and we get m equals to 166.67. But in terms of miles, we don't really count 166.67 miles. We're going to round this up to 167 miles. So after 167 miles, plan B actually becomes cheaper. And let me show that to you guys just so we understand what's going on. Now, let's say that we have these two plans, plan A and plan B. But now, instead of driving 10 miles, we're going to drive 167 miles. Now, under plan B, no matter how many miles you drive, it's unlimited. The cost is fixed. It's always going to be $50. But under plan A, let's see what happens. We have a fixed fee of $30 plus 12 cents a mile. Now we're driving 167 miles, so it's going to be 0.12 times 167. Okay, so let's figure this out. We have 0.12 times 167 plus 30. That cost comes out to be $50.04. So if we drive 167 miles, plan B is actually going to be cheaper than plan A. All right, now these three are going to be important things to know. The demand function. In a free market, the price of an item increases, the demand decreases. So let's say an iPhone costs $10,000, then most of us probably would not buy one. But because iPhones only cost $800, a lot of us do buy iPhones. So as the price of an item increases, the demand decreases. If the iPhone costs $10,000, there's going to be a lot less demand for it. But as the price decreases, the demand increases. The demand function can be written as d of x equals to mx plus b, where d of x is the quantity demanded and x is the price. Supply is given by S of x equals to mx plus b. Now with the supply, as the supply of an item increases, the price decreases. So let's say that there was a lot of a particular item, then it becomes not as valuable. So the price is going to decrease. Equilibrium price is the market price where the quantity of goods supplied is equal to the quantity of goods demanded. So basically, this is where d of x equals to s of x. That is the equilibrium point. So here's an example. In supply and demand problems, y is the number of items the supplier will produce or the public will buy if the price of the item is x. For a particular product, the supply equation is y equals 4x plus 560, and the demand equation is y is equal to negative 7x plus 1044. Find the equilibrium point. The equilibrium point is where the supply is equal to the demand. So we have our equation 4x plus 560 equals to negative 7x plus 1044. To solve this equation, we would move the negative 7x to the left and the 560 to the right. So we would get 11x equals to 484. Then we divide both sides by 11 and we get x equals to 44. So what does x represent? X is the price. So when the price is $44, we are in equilibrium, which means the supply and the demand are equal. So what is the selling price when supply and demand are in equilibrium? We just said that, it's $44. What is the quantity supplied when supply and demand are in equilibrium? Now remember, d of x is the quantity. So we can say that d of x is equal to negative 7, this is our demand equation, times 44 plus 1044. And that will come out to be 736 units. We could have also plugged in the price 44 into the supply equation, and we will get the exact same answer. Okay, so this is the answer for part C. Here's an example. The total cost in dollars to produce Q units of a good is given by the function C of Q equals to 7.8 Q plus 54,000. So we always have to understand what each of the variables mean. So C of Q is the cost, and Q, this is the quantity. What is the total cost? So we're looking for C of Q to produce 5,700 units. Remember, Q is the number of units produced. So we want to figure out what is C of 5,700. The equation is 7.8 times the quantity produced, which is 5,700, plus 54,000. Okay, so the cost to produce 5,700 items is equal to 98,460. And as always, don't forget the units. We should always have units on all of our numbers. How many units can be produced? For a total of $64,140. So this is the total cost, which means C of Q, or the cost, that whole thing will get replaced with 64,140. So remember, our equation is this: C of Q is equal to 7.8 Q plus 54,000, where C of Q is the cost. So since we know the total cost is 64,140, we're going to replace this whole thing with 64,140 equals to 7.8 Q plus 54,000. Okay, now we want to move the 54,000 to the other side to solve this equation. So we get 10,140 equals to 7.8 Q. We divide by 7.8 and we get that Q is equal to 1,300 units. So when we produce 1,300 units, our total cost is $64,140. Okay, another example. The demand for a product is given by the following function. D of Q is equal to negative 0.009 Q plus 91, where Q units in demand and D of Q is a price per item. So now let's, again, we always have to define what our variables are. This is the price and Q is a quantity. Always keep in mind what these variables represent. If 9,300 units are in demand, what price can be charged. So this is the quantity. Where does the quantity go? The quantity, it replaces the Q variable. And D of Q is the price. That's what we're looking for. We're looking for what price can be charged. So D of 9,300, this gives us the price for 9,300 units is equal to negative 0.009 times 9,300 plus 91. Okay, if we put this in a calculator, then we're going to get that the price of each item is $7.30. So this means if we charge $7.30, we will be able to sell 9,300 units of this item. And here's why this is important. Later on, we're going to talk about how to maximize profit. And in order to maximize profit, we need to figure out what price do we have to charge in order to produce a certain quantity, and that quantity will maximize profits. But that'll come a little bit later. Okay, so now let's talk about cost, revenue, and profit functions. So a linear revenue function can be a linear cost function is C of x. It's usually the fixed cost plus the number quantity produced times the cost of producing each item. The revenue function is the number of items sold, which is x, times the selling price of each item. Right? So like let's say that we're selling something for $10 and we sell 3 of those items, then our revenue will be 10 times 3 or $30. Now the profit is revenue minus cost. So revenue is how much money is coming in minus cost, how much money did we pay to make those items, where X represents the number of items. Okay, example. You decide to begin selling bags of goldfish at the local art festival. Your cost for each bag of goldfish is $169, plus you have to pay a fixed weekly fee of $160 for the booth. You have a booth, so you got to pay $160 for the booth, whether you show up or not. You got to pay the $160, and then each bag of goldfish costs you $169. So you plan to sell the goldfish for $3.65. Okay, part A. Write a cost function. So what does our cost look like? So we got to pay for the booth, which is the $160. That's a fixed cost for the week. Doesn't matter if you show up, don't show up, you got to pay the $160. But for each bag of goldfish you sell, we have to pay $1.69. So this is our cost function. Our revenue function is the number of items sold times the selling price of the item. We're selling each goldfish bag for $3.65, and let's say we sell n bags, so our revenue is going to be 3.65 n. Now profit is revenue minus cost. So the revenue function is 3.65 n. Always use parentheses when you replace a variable with an expression, minus the cost function, which is 160 plus 1.69 n. Remember to distribute the negative. So this is going to be 3.65 minus 160 minus 1.69 n. So our profit function is going to be as follows. Our profit function is going to be 1.96 n minus 160. Okay, this function here is going to be our profit function, which is revenue minus cost. What is your total cost if you produce 370 items? So part D, E, F, and G, we will go over these in class.